Welcome, Java learners. In this video, we will be getting to know how to calculate the range of data types. So, let's get started. In a previous video, we have seen what the data types present in Java are. We also learned that each data type has some specific range with specific use cases, and we need to use them as per our requirement to optimize the space. I recommend that you watch that video, and you might get to know something new. But the question is, can we keep all those ranges in mind? For example, short ranges from -32768 to 32767, and there are a bunch of other data types ranges. Nope, we can't. Even if we can, there will be some point where confusion will occur. So to make it easier and to simplify, we have a formula to calculate the range of data types. We just need to remember how much space each data type consumes, which is simpler than keeping their ranges in our minds. For example, for byte, it's 1 byte. For short, it's 2 bytes. For int, it's 4 bytes. For long, it's 8 bytes, and so on. So, let's see what is the formula for calculating the range. Before we jump directly into the formulas, we need to know something. Just like our SD card is measured in gigabytes, GB, with 1 gigabyte being made up of 1024 megabytes. But now, if we go to Google and search 1 gigabyte is equal to 1024 MB, we will see a conversion saying that 1024 megabyte is equal to 1.024 gigabyte of memory. Now you might get a question which one is correct then, but there is a point to know. If we change megabyte to Mebibyte and gigabyte to Gibibyte, we can see now that 1024 mebibytes is equal to 1 gibibyte. This is because megabyte and gigabyte give the value in decimal format, and mebibyte as well as gibibyte gives value in binary format, so there's no need to be concerned about these differences. Similarly, in computing, when we talk about bytes, a byte is made up of bits. 1 byte is equal to 8 bits of memory. But now the question is, what is bit? A bit is the fundamental unit of digital information in computing and telecommunications. The term bit is derived from binary digit, and it holds a pivotal role in the digital world. A bit can represent one of two values, 0 or 1. As we know, computers can understand only binary languages, which are zeros and ones. But have you ever thought about 0 and 1? How can computers even know what 0 and 1 mean? How is it possible to convey to computers that this is 0 and this is 1? We all know the CPU is the heart of every system. It is made of semiconductors. When current is passed through a semiconductor, it is denoted as 1, and when current is not passed, it is denoted as 0. Now, let's take the example of the int data type, which typically uses 4 bytes of memory. We know that 1 byte is equivalent to 8 bits of memory, so for int, we have 4 multiplied by 8, which equals 32 bits. To calculate the minimum range, the formula is -2 to the power of n-1, where n represents the number of bits. We have n-1. This 1 bit reduced is used to indicate whether the number is positive or not. For int, we can say -2 to the power of 32 minus 1, which gives us -2,147,483,648. Similarly, for the maximum range of the int data type, it's 2 to the power of 32 minus 1, which will give us 2,147,483,647. We have done an extra -1 from the whole number while calculating the maximum range. This is because 0 we have already taken into consideration while counting the minimum range, so we subtract 1 from the whole. These calculations illustrate the range of various data types while taking into account the bit allocated for the sign, enabling us to represent both positive and negative values within the specified memory space. Now you should try for other data types. Thank you for joining us on this incredible learning journey. We're committed to providing you with the best possible resources to help you master Java programming. Don't forget to subscribe to our channel and hit the notification bell so you never miss an episode of our Java learning series.